Okay, probability. We're in part B of probability, and what you just learned yesterday was how mind-bogglingly big factorials are. And they're basically about doing permutations or combinations, but permutations are the really big ones. That was the one like where I said if there was a bus in the parking lot, and we all went out there into this 25-seat bus and rearranged into all the possible, not combinations, but what? Permutations. Then it was 50, well, no, that was the deck of cards. The deck of cards was 52 factorial. This one was 25 factorial, and that was a ridiculously big number. Okay, now I want to make sure that you've got this so far. Imagine for a moment it was simpler. There was 4 things on my desk. Cookie, die, remote, and worksheet. Okay. If I had these 4 things to choose from, and I was going to take them out, can you grab that? Thank you. I was going to take them out 2 at a time. What problem did I just give you? I'll say that again. 4 things. You're going to take them out 2 at a time. Did I ever say that the order mattered? Excuse me. I'll pause the video for a second. Okay. Sorry for the interruption there. I don't even know what I was asking, so I will try it again. If I have 4 things, and I'm going to take them out 2 at a time, did I ever say that the order mattered? No. If I didn't say that the order mattered, then it must be 4C2. All right, try to calculate that right now without a calculator. Give me some collateral, hurry up. Okay, so you might have forgotten from yesterday what a C versus a P is, and it happens all the time. C stands for combination. P stands for, we said it a second ago, permutation. Okay, so what you should have remembered from yesterday was that we did 4 factorial over, is this ringing a bell, 4 minus the 2 factorial, and with C's there was an extra one of those, 2 factorial. Now, I could just say, well, use a calculator for it. But the reason I'm not is because I've seen this on the ACT where it's written as a formula, and they're like, which formula is right? And you can't use a calculator to do that. All right. So, actually, you could, but it would be really long. So, this was 4 times 3 times 2 times 1. 4 minus 2 is 2 factorial, which is 2 times 1. And then I'm going to make this in a different color just so you can see it's the other factorial, 2 times 1. And there's a times between them. Final answer. 2 and 1 cancel. 12 divided by 2 is 6. All right, if you hadn't caught that, I'm going to give you another chance to redeem yourself here. Let's say I add an item to my little list. Now I have a cell phone up here because somebody was borrowing a calculator. So now I have 5 things. I'm going to choose them out 3 at a time. 1, 2, 3, 4, 5 things, but I'm going to pick out 3 at a time. Like I'm going to happen to pick the die, the cookie, and the remote. Well, what was the probability I'd pick that? That's a different question. That's what I want over what's possible. But for right now, it's just all the different ways you could pick out 3 things out of 5. And remember, it didn't seem like I cared about the order. 5, C, 3. What goes on top? Row 1, person 1.
5.
It's called factorial. Okay, good. And on the bottom, row 3, person 2. That's you. 5 minus 3 factorial. And since it's a C question, very good. Everybody without a calculator, you need to know how to do this without a calculator. Do you remember last time when we were doing matrices? And when we were in matrices, you also had to know how to do it without a calculator because we'd throw a letter in the middle of it. and that messed it all up. Calculator wouldn't work. Could you do that on this? Absolutely. What if I said 5CA? You could still do it, but a calculator wouldn't help. Okay, on the top, on the bottom, 5 minus 3 is 2 factorial, which is the same as 2 times 1. And 3 times 2 times 1 for that one. And this will cancel. This, 20 over 2, answer's 10. Raise your hand if you had 10. Awesome. Now that one, the order didn't matter. Do you get that if I make a distinction between die, cookie, remote, and if I say that's different than cookie, die, remote, I just changed the order. If you're going to say the order matters, then the order patters, P, permutation. All right, so whenever I see a P, I think, oh yeah, so you're saying, Mr. Server, that the order matters. All right, so I'm going to do one where I still keep it to 5 items on my desktop because that's what I have. And I do 5P2. I'm going to take out 2 items at a time. And if the order matters, like, oh, cell phone cookie versus cookie cell phone, if those are different, then the order matters and then there's a different answer. Peace. Do you remember, it's a lot like the other one, but it's actually simpler. The other one had an extra number on the bottom. This one just has the 5 minus 2 factorial on the bottom. So then that becomes 5, 4, 3, 2, 1 over 5 minus 2 is 3 factorial, 3, 2, 1, cancel, cancel, 5 times 4, 20. How come the other answer was bigger? Because then the order mattered. In this case, the order doesn't matter. All right. So let's talk, and man, the other class was really bad at this, and I imagine you might be also. So we're going to do A, B, and C. This thing I'm about to do, a lot of people get confused on which one to use. Do you use a C or do you use a P? That's what today's lesson is called, is combinations versus permutations. Permutations is where you rearrange the bus and you just get all these different combinations, and they're huge answers. All right? Combinations are where you don't rearrange them. So let's do a combination right now for the class. If I had 25 kids in here, and I say, I'm going to pick 2 kids out, just any 2 kids. Am I going to rank them? Nope. Are they having a race? Nope. I'm just going to pick out sets of 2 kids. Like I'm going to randomly pick you and you. That was relatively random. I didn't go with people in the front row, though, so maybe it wasn't random. Anyway, that combo. Do you get, there's a lot of different combos I could pick. Do you get that the order does not matter? You, her versus her, you, doesn't matter. Same thing, same combo. Okay, so we're not doing permutations, we're doing combinations. 25, 2 people chosen. What's the problem? What's the answer? This one's so big, I'd like you to use a calculator for it. Okay, first, for A, this is the part everybody gets wrong. I tried to make it really clear. Do you think it's a C or do you think it's a P question? Combination or permutation? How can you tell? It's all about, did the order matter? Do you remember in this scenario, if I just picked 2 random kids, did the order matter? Nope. Therefore, it's a C question. Go ahead, use a calculator, use C, and figure out the answer. Pausing while I pull up my calculator. Okay, so did you know that was 25C2? Raise your hand if you knew that. Awesome. Now, I said that this one would be really tough to do without a calculator, but it actually really wouldn't be. 25 factorial over 23 factorial with an extra 2 factorial, and they're multiplied. And what's the top? I am not going to write out 25 times 24 times 23 times 22 all the way down, right? That's kind of dumb. I know what it's going to do, though. And do you get the 23 factorial all the way down to 1 is going to cancel a lot of stuff? You know what I'm saying? Dot, 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 dot. On the bottom, it's this. I'm just going to put in one more. I'm going to put in the 23. Dot, 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 dot. Do you get that that's going to cancel that? And then there's an extra 2 factorial on the bottom, which really means extra 2 times 1. I think there's somebody talking in the back, and it's like, okay, you guys doing some math? Yeah. All right, all right. So I'm going to go 25 times 24, and I'm going to divide it by 2. So it isn't that bad by hand, but be a little nicer if you had a calculator. So I'm going to show you how to do it, 25C2 on a calculator. 25. Easiest thing is to put in the first number first. C2. C, where the heck is C? Well, you can go under the catalog and everything's listed there, but it'll be a little faster if you know where the math button is. And arrow over to probability. And then there it is. C, not P. P would have been if the order mattered. 25C2, enter. 300, raise your hand if you had 300. Okay, awesome. Predict. If I did this as a permutation, would there be more or less answers? More. Go ahead, use the P. And then this would mean that the order mattered. When I picked kids, I was picking like president and vice president. There's quite a difference there. One is higher than the other, and so therefore it would matter. The order matters. If I pick you president versus you president, it matters. Okay. So hopefully you did 25P. Two. 600, twice as many. Think about why that's logical. If I grabbed these 2 kids right here and then said, oh, the order matters, do you get there's going to be just simply twice as many combos? Because I got to switch them around. So it's either this way, or that way, that way. So order matters. It isn't always double, though, because what if I had 3 people? Do you get if I picked 3 people and I was giving out medals? The blue ribbon, the silver, and the bronze, okay? If I pick these 3 people, there's 6 different ways that I could rearrange them for first, second, and third. So then it's going to be 6 times as big. All right, so P's and C's don't always think, oh, they're always twice as big as each other. Nope. Depends on how many you're pulling out and how many rearrangements of those you could do. Okay, so next part, for part B, I'm giving you a break. All I want to know is, do you think this next problem is a P or a C question? And set it up. Don't even get the answer. Just set it up right with either a P or a C. There's 25 of you. Let's say I decide to have a basketball tournament. And so I pick random groups of 5 kids, because to play on a basketball team, you need 5 kids. All right? So you're going to play full court games, you know, and I'm going to pick these 5 kids and then randomly pick a different 5 kids. Okay, how many different groups of 5 kids could I make? Set it up. You don't need the answer, you just need to set it up. C5. Why didn't order matter? I picked 5 people. It's not like I picked a number 1 person, a number 2 person. It's not like there was a rank. How many of you knew it was a C? Raise your hand if you did. Okay, awesome. This one gets a lot of people, so pay attention. Part C, just set this up. I have 8 books on a shelf. These 8 books could be rearranged. And then, like, you come back in and your little sister has rearranged your books. Dang it. And you're going to rearrange them back the way you like them. How many different ways could the sister have rearranged the books? 8 books on a shelf. Notice I didn't say she pulled out 4 books. She rearranged all 8 books. There's still 8 books on the shelf. You get how this could happen in real life very easily, right? You got 8 things and you could rearrange them. Is it a C or is it a P? A lot of people aren't saying because I think they're not sure if they're right. Show the kid next to you if you thought it was a C or a P. She needs a partner too. You're the only one who can do that. So. Here's a harder question. 8P what? Mm-hmm. Now I want you to figure out, should this be a simple, small number answer? Isn't this kind of like the 25 people on the bus question, except there's just 8? Isn't there a lot of different ways to make that book rearrangement? If you had asked most people before this unit started and you realized how, oh, by the way, it took the rest of your life to rearrange in the parking lot, in the bus, your whole lifetime, you still wouldn't get them all done. I think given that context, you know the answer is fairly big. Would you grab your calculator and actually figure out 8P8 though? 8 books on a shelf. How many different ways could there be? Eight, math, $40,320 ways. Just for a second, let's just think about how long that would take you to just take 8 books on a shelf and rearrange them into all the different ways. Let's see, how long do you think it would take you to do a rearrangement, like a shuffle? Like half a minute, 30 seconds? You also have to kind of try to keep track of what you've done and what you haven't done. I mean, that would add a lot of time, but let's just say it takes 30 seconds. Half a minute. Then it's going to take 40,000 half a minutes. So then that's how many minutes? It's about 20,000 minutes. 20,160. And that's minutes. I'm going to divide that by, what do you think, so I can make it hours? 336 hours. Now I'm going to divide by, what do you think I'm going to do? Divide by 24. 14 days straight with never even stopping to eat, go to the bathroom, sleep. 14 days straight to rearrange the books that many times. Isn't this crazy? It doesn't seem possible it would take that long to take 8 little books and rearrange them into all the different ways. Those are called permutations. All right, I think you got the idea. They're big. If you got nothing else out of yesterday, that's what you were supposed to get, plus that little formula. And then today, you're supposed to mainly get how to decide whether or not the order matters, because if order matters, it's going to be a P problem. If order doesn't matter, it's going to be a C problem. Yes, sir?
Why was the one with the 8 books permutation?
Okay, now I want you to just ponder for a moment. If it wasn't a permutation, then it would be 8C8, right? And think for a second. If I did that on the calculator, the answer would be 1. Do you think there's one way to rearrange all those books? No. So it's a permutation because the order matters. Do you get, if I shuffle the books, then the order is different and the order matters? If you don't care what order the books are on the shelf, then there's only one way to do it, and that's just to put all 8 books up there and you're done, because you don't care about the order. That would be a C. If you care about the order, it's a P. If you actually use a calculator to figure this out, the answer would be 1. And you know there's not just one way to rearrange those books, right? Okay, so that's why it's a P. All right, so back to blanks. There's 4 spots in this picture. Back before Facebook, there was a thing called MySpace. And there was 8 places where you could put your friends in. It was the top 8 places. And you could put your top 8 friends on your, kind of like a Facebook page, except it was called MySpace. It's amazing how MySpace just got totally destroyed when Facebook came in. Why? Because Facebook was cool because it was all the college kids. It's really amazing. And it wasn't just the college kids, it was the cool college kids because it started at Harvard. Remember who the dude was? Zuckerberg. And so everybody had envy of, Facebook was basically the same thing as, I know he would say, oh, it's totally different, but it's basically the same thing as MySpace. And MySpace all of a sudden was not cool because Facebook was cool, and then holy cow, everybody was on Facebook. And now, like, half the world's on Facebook. It's insane. Not half the world, but it's over, how many billion is it now? Do you guys know? No, that's how many people are in the world. I mean, how many Facebook accounts? There's not as many as I know it's getting close, but all right. Well then, your top 8 spaces, let's say it's top 4 spaces. Let's say you've got 12 friends. You've got to pick only 4 of them to put on your top 4 spaces. Okay? Your 4 besties. You got 12 to pick from. What's this problem really the same as? Would you please write down what you think the problem is as a P or a C kind of question? And then try to answer it this way with blanks. You got 4 blanks, you got 12 friends. You should be able to do it both ways. I'll show you how in a second, but I want you to struggle with it for just a minute first. I'll pause for a second. Okay, it all depends on if the order matters. We're going to say that since they are distinct separate places, and your friend could be on the left or they could be on the right, that those are different, and therefore the order matters. The order P, order patters. So you should have said 12 friends, got to choose 4, and the order matters, so it's a P. Now, I totally get if you thought it was a C because you don't care what order they're in, then it would have been a C. Now, I'm telling you now, and they'll have to tell you on the test. Does the order matter or not? Order matters. It's not a C, it's got to be a P. Then if it's 12P4, here's another way you could have done it. How many choices do you have for this first spot on your page? 12 choices for that. Can you repeat your friends? No, that'd be pretty sad if you had to like repeat friends to like fill in your spots. Okay, but we're going to not repeat friends. So then this is 11, and this is 10, and this is 9. Then when I multiply that out, that's how many different ways you could have set up your page. Okay. That's my calculator. It better still work. All right. So if you had a friend who said, hey, could you make sure, like, I'm really into, like, numerology, and I don't want to be in the first, second, or third spot. I want to be in that last spot because 4 is my lucky number, and I also generally tend to like the right side versus the left side. There are people that really have things with numbers. Like, I'll give you an example. I had a kid where we numbered off in class, and they were a number that they could not deal with. They said, I can't be that number. Please give me a different number. Sometimes people have things with their personality that they just can't handle certain things or numbers or names or whatever. So I had never had that. I've taught 28 years, but it's only one time that somebody said, I need you to give me a different number. I can't be that number. I really would love to explain the rest to you, but I can't. So your friend wants to be in the 4th spot. How many choices do you have for the 4th spot then? Only one choice for that. Then how many choices for the first spot? 11, 10, and 9. A lot of people would have said 12 kids because I could pick anybody. No, you couldn't pick anybody to go there because your one friend wasn't going to be able to be there. Okay. We all have our things. I had another kid who was severely afraid of balloons. Not kidding. If a balloon came in the room, they would have to leave. There was no way they could deal with it. Some of you guys are afraid of clowns. I've heard it's 43% of people are afraid of clowns. Now, that doesn't mean like terrified would run out of the room. Be honest, how many of you guys are scared of clowns? You have a thing about clowns. Okay, nobody's going to admit it now. And on anonymous surveys, 40% of people say that they are scared of clowns. I think I went overboard with my daughters. I had this little marionette clown, which makes it even more creepy. And it became a joke after a while. I would like hide it in their room. One time, one of my favorites was I hid it underneath a pile of stuffed animals so that only a foot was sticking out. And then she saw the foot like it was hiding in the in the pile of stuffed animals. Favorite memories. One time I had it hanging up in the corner of the room. So when she went to sleep and all of a sudden looked up in the corner of her room, she was like, "Oh my gosh, there's a clown up there." Anyway, okay. I maybe teased a little too much with clowns. Now, don't worry, they're not like severely afraid of clowns, but you know, it's not their favorite thing, especially not the ones that have the sharp teeth and you know, creepy glares. All right. So let's say you have a password because I now need to keep the clown in a safe to keep them from stealing it because you know eventually they were like, I'm not going to let you torture me with the clown anymore. I'm going to steal the clown. So now I got the clown locked up in a safe, and it's a 4-digit number. How many possible numbers are there? How many possible passwords are there for my safe? Well, how many numbers are there that could be right here? And it is important to know. There are some safes where you can have like a 2-digit number for each spot. That's not what I meant. I meant a single-digit number for each spot. Kind of like the passcode on your phone. Well, then, if it's 0 through 9, a lot of people say, so that's 9 numbers. No, what is it? It's actually 10 numbers. Then here's how many passwords you could have. You multiply your choices. But what if I have a thing with the number 9? I'm just don't want to use 9 because it's not a lucky number for me. Okay? Well, how many choices am I going to have if I can't use 9s? I have 9 choices for each number. Okay. How about this? Here would be another example of how they might say this kind of question. There's 4-digit number. Do you agree I could, if it was like 7954, do you get that that could be interpreted as 7,954? Okay. What if my password needs to be above 5,000? How many choices do I have now? If my password needs to be above 5,000, just to clarify, that means 5,954 would be okay. So don't like say, oh, 9s can't be used. No. If that's above 5,000, isn't it? All right, figure out how many passwords there could be that are 5,000 or above. Just to clarify, 5,000 itself would be okay. Or anything bigger than that. This one usually stumps people, so pay attention. Pay attention to the answer on this one. If this has to be above 5,000, would you agree that this number has to be a 5 or bigger? So it's a 5 or a 6 or a 7 or an 8 or a 9. Those are all work. So how many choices do I have for the first spot? 1, 2, 3, 4, 5 choices. How many choices for the next spot? 10 choices. Could you have any number there? I don't care about what those numbers are, because as long as it starts with a 5, you're good. All right, how about this? Your number can repeat. You can have the same number, except the last digit has to be a 4. 4-digit number. Number can repeat. Last digit has to be a 4. Well, then I would start with the last digit and say it has to be a 4. Don't put a 4 here. That's a really common oops. Because you're supposed to be putting choices there. How many choices do I have for the last number? I don't have 4 choices. I have 1 choice for the last number. If it has to be a 4, I only have 1 choice. This is about choices. And then I have 9 choices, 8 choices, 7 choices. Why wasn't this 10 choices? Because I already used 1 up. Why did I say it could not be a 4? The numbers, oh, you're right. The numbers can repeat. You're right. I did say they could repeat. You're right. So that makes a totally different answer. If they can repeat, then I could have any number here, and it wouldn't matter. So 10, 10. We do a lot of problems with people. One of the things you're going to be able to assume is that people can't repeat. As in, if I have you standing here, I can't have you also standing here. Okay? So if it's a people problem, you can assume they can't repeat. There's no cloning. Wouldn't that be weird? Exactly you. There's movies about it. So far, they haven't been able to clone humans yet. And they think that it may not even be possible. They have been able to clone sheep. True. But then there's apparently something quite different about, well, obviously we know there's a difference between humans and sheep, but there's something biologically quite different that makes it way harder to clone a human than a sheep. So I'm not saying there isn't. I guarantee you that in some dark lab somewhere they're trying. You know, I'm sure somebody's trying, even though most of the governments have agreed not to mess with that. It's still one of those things. They're trying to clone humans right now. But anyway, for now, you can assume that there's only one of you. So if this is a picture with people, it'll never repeat. If there was 10 friends, you can't go 10 times 10 times 10 times 10 because you can't have the same person in all 4 spots. Okay. I think it's time to start your homework. So I'll show you how we're doing that. I'm going to pause for a second. Oh, before I do, you now need to Dropbox last night's homework. So everybody right now, take a minute out of whatever you're doing, because if you don't Dropbox it now, if you don't turn it in, it will not count. You need to Dropbox it now if you have it. And last hour I was kind of surprised how many kids didn't have it. But I know it's a busy time of the year, but I need to keep you accountable for getting your homework done. So turn in your homework. I will grade it myself. Just in case you're not clear on what that is, you're looking for the Dropbox for probability B, and within that, okay, it's this one here called permutations and counting, and you should have Dropboxed it right in here under the homework, but if I click that, it's going to pull up all the names of you that have Dropboxed it. I don't want that going on the video. Okay, so right here, Dropbox it. Now, it says it's due today, Tuesday, May 7th, and I'm going to fix that for your hours, so pausing for a second. So I got it fixed, so you got 7 more minutes to turn this in. It's last night's homework. You're going to want to turn in the homework before 8 a.m. Once you get in the hang of it, 8 a.m. is going to be the magic number. You have to turn it in by 8 a.m. Not during class, but you do it at night. You turn it in hopefully at night. But some of you would like to work in the morning. It's fine. Just get it in before 8 a.m. And late work, unless you want to give up, your 2 lowest are thrown out at the end. You don't turn in things late. All right, moving on. Okay, it's called permutations / combinations homework. It's got the little puzzle piece, so it's a Schoology quiz. I will start it with you right now, and you get more time than normal to work. All right. So there are 20 players on a hockey team. How many different ways can the coaches pick 2 captains? Well, actually, all it asks is it a P, a C, or neither? What? I don't understand. You mean it asks for both answers? Oh, it's got two. Okay, thank you. Good point. All right, at the top, you actually have to figure out the answer. At the bottom, it's was it a P or a C? All right. Captain sounds to me like a ranking thing, but there's two captains. Do you think, from your experience with captainships, that there's a like a head captain and then like an under captain? I don't think so. They're like the same. So that means this is not a P. You should be doing a C on this one. C for problem one. All right, so what C what? Well, there's 20 kids, so 20 C. How many captains? 2. 20 C2. Your calculator is totally okay to use for this. And you do that, and you put the answer in this blank. And then this blank is where you put the fact that this was a C, because there isn't a captain that's higher than the other captain. Okay, moving on to number 2. Is it a permutation or a combination? Notice this time it's just that. Is it a permutation or a combination? You have a collection of Justin Bieber CDs. How many ways can you arrange them? You guys got this last time, except I said it was books. Arranging the CDs. Permutation? Combination. Which one? Permutation, correct. Yes. So we'll get to this. Is it the next one is probability, or is the one after that? Is it problem 3? All right. I will scroll. I think number 3 is fairly easy. Let me just look at it quick, though, with you. Look at number 3. 3 letters, 3 digits. These are letters. These are digits, as in like 1 or 0 through 9. All right. Normally, I would say that it would be 26 letters, 26 letters, and 26 letters, and 10 numbers, and 10 numbers, and 10 numbers. But there are some big, like, conditional things here. So you don't just multiply 26, 26, 26, 10, 10, 10. It says the first 2 letters must be M and N. Then that means I don't have a ton of choices. I have one choice, M. One choice, N. 12-minute warning. And then the last digit needs to be a 5. I don't have 10 choices for the last digit. It has to be a 5. Don't put a 5 there, though. How many choices do I have if it has to be a 5? One choice. There's an example of how you would do number 3 with the blanks. I wish this was easy, but it's not. And it's the spring when it's hard to concentrate. All adds up to this might be a little challenging, but you got to admit, I've done the first 3 problems with you. Okay, now I'm going to go to one that's a probability. All right, for number 6. Do you remember probabilities are what you want over what's possible? I hope you remember that. So it's what you want over what's possible. And this, what we're talking about here is outcomes. All right? So please look at number 6 with me. It's hard to concentrate when you guys are talking about other things. Unless you're talking about number 6. The combination is 3 digits long. Okay, so then that means I got 3 numbers here. Please stop talking. I was trying to be nice about that, but... And then I have 3 digits that, let's see, the possible numbers are from 1 to 20. Oh, okay. They can be 2-digit numbers. I get it. So there are 20 choices for this, 20 for this, and 20 for this, unless they make some other conditions like, oh, the first number has to be a 5 or something. All right. What's the probability? Oh, wait, these are all the possibles. That goes down here because that's all the possible combos that there are. What's the probability that their combination consists of all odd numbers? Well, then, how many odd numbers are there for the first, second, and third number? Again, this is down here. how many choices do I have if it has to be an odd number? Yes. Oh, okay. One thing at a time. Given the numbers cannot repeat. Okay, good. I agree. But how many odd numbers are there? Still, the question remains. 10. Then, if they can't repeat, don't say 10 times 10 times 10. It's going to be 10 times 9 times 8. What I want over all the possibles. Okay. Warning you. Last test, hardest test in the last 4 tests. Don't be like, oh, I'm scared, I'm going to fail. Just make sure you step up and get your homework done. And beyond just doing your homework, the next logical step that some people give up on is like, oh, I'm doing it right every time. The last couple of units might have lulled you into sleep thinking, nah, this class is so easy. I don't even need to check my work. Check your work, especially this chapter. There's answer keys for a reason. Use them. This one, after you're done, it'll say whether you've got the, and it'll even tell you what the right answers were. Okay, so make sure you check that. Do you remember that on Schoology quizzes, if you get a 75% after trying it twice, if you get a 75% average, or 75% the first time would be fine. I get a 75%, I'm giving you full credit for it. So I get, you're going to get a few wrong. 75% is actually pretty good, considering you're still learning this stuff. When you hit the test, we want you to have more like a 95%, right? But when you're still learning it, 75 is not that bad. All right. That's all I got for you for today.